So the title of this is Chris Van Matre proves the Earth is a globe. And I'll get into why I'm saying that through this presentation tonight. So for anyone that tuned in to the live hangout we did Sunday, right now it's Tuesday the 13th. We met on the 11th at 9 p.m. Eastern, and it's on my channel. You can go watch that. And it ended abruptly and what's the word? Well, strangely. I didn't expect that to happen. But hey, you know what? I still have questions for Chris. So I'm going to continue asking these questions. And I have some here tonight that I'll go through. And it's unfortunate he doesn't want to participate in this because I think it's an opportunity for him to make his case. I keep saying that he's a surveyor, I'm a surveyor. We both use the same equipment. So, and that's my interest here. He believes the Earth is flat. Of course, I don't. So, what's the harm in talking about it? And why get so emotional and hostile or whatever? You know, there's no need. Just bring your measurements. Like I said, you can talk all you want, and you can dig up old books that claim all sorts of things, but isn't the idea that we're supposed to do our own research and test things out for ourselves? So anyway, I think that's enough of like an intro. So let me go ahead and go through these slides. So the first one, I'm kind of picking up with this idea of his, and I'll ask this question. Oh, by the way, I'm going to also I want to say this as well. These are my questions for Chris, but I hope that these questions would be the same kinds of things other people would want to ask him. Like, for instance, I think he's going to be presenting at this conference coming up in a couple days over there in Denver. The, what is it? The International Flat Earth Conference. And he's lecturing on these ideas of his about the flaws in theodolites and so forth. So the unfortunate thing is that the people who are attending, they're not surveyors, so they don't know one way or another. So because Chris believes in the flat Earth and they believe in the flat Earth, whatever Chris says about surveying instruments, they're going to say, aha, see, there it is, there's the problem, or there's the deception, whatever, however they want to characterize it. But what about some of the surveyors? There are surveyors who are falling for this flat Earth business. I'm hoping that they would have the presence of mind to look at these questions that I'm going to ask tonight and ask them and say, yeah, Chris, what about this? Why don't you show Jesse how the Earth is flat based upon your measurements? Okay, I'm going on a slight tangent, but it's related. Basically, I'm just saying, maybe my questions are the same questions other people will have, and ask him, especially if he gives a presentation at that conference. Bring up some of these questions and talk about it. So if surveying instruments are incapable of measuring accurately as you believe, then how can you claim your survey work is accurate? And that's what happened the other night. That's what he said, and that's what he claimed. So I'm going to show you this document, Standards and Specifications for Geodetic Control Networks. And that is right here. No, that's my email. All right. All right, that's this document here. It's online. And in the Hangout, I did mention the video I did that is basically called Survey Standards and Specifications. You can go look at that video and look in the pinned comment. I left links to all of these documents. So the main thing that I keep talking about is triangulation, because I didn't realize he believed that GPS was okay. He believes GPS is okay and he uses it all the time. So I've got a slide about that a little bit later, but I've emphasized triangulation because that's how things were done long ago. That's how all the maps that we use have been produced. He's saying they're going too far, they're overextending the capability or limitation of the instrument and so forth. Yet at the same time, that's what he did in his little test he did, the 2 miles to the telephone pole. He's using his auto level way beyond the limitation. So it's really hard to it's hard to wrap my head around where he's going. It seems very inconsistent. So maybe he needs to kind of clarify that. Yeah. So anyway, take a look at this. You'll see the station spacing. You'll see the number of positions that are measured, standard deviation not to exceed, and so forth. The least count of the instrument is a 0.2 second instrument used for first and second order triangulation. Yada yada yada. You can go through this document and learn all about that. Yeah. So I wanted to show you that. And again, it's in my other video where you can go get this thing, and he should already have it. All right. What's next? So, can you define the amount of error you claim you've discovered exists within surveying instruments that cause them produce flawed and inaccurate results? So, I mean, it's one thing to say that the instruments have imperfections in them. Well, we know that, and that's why we do things the way we do them, to account for the imperfection in the instrument, or if you want to call it a flaw. That's why we measure angles in face one, face two, direct and reverse. Either way, you could say it either way. We have methods and procedures that assure the results will be accurate. Now, I'm getting this sense that he doesn't understand that. And especially with this test here, he definitely doesn't understand it. And he's taking it very personally that I'm pointing this out to him. I can't help that. He's the one that did this test. And, all of my tests, everything that I've done over lakes, over water, on land, up high, down low, everything I've done, short tests, long tests, I follow the specifications that I just showed you on that last slide. That's how I operate. I'm using survey methodology, and that's it. I'm not bringing anything else to this. So we need to know from him, this flaw that he's talking about, how extensive is it? Does it make these instruments unusable? Does it make them somewhat usable? In his test, I have it in quotes. I don't think this is a test at all, but he notes a difference between these two instruments, 2 feet in around 2 miles to that telephone pole. And if you compute the drop of the curve from in that distance, it's under 3 feet. So, it's not a convincing test of anything, except to show that these two instruments are pointing at 2 different spots on that telephone pole. So I don't, that's it. I'll just move on. So that's the idea here is answer that question. This flaw that you keep talking about, what is it? How much does it add up to? What does it amount to and is it a constant growth? If this happened, if it's just under 3 feet, I'm sorry, if it's just under 2 feet in 2 miles, is it double that in 4? And what is it in 10? How does this flaw behave? Have you characterized it? Have you made sufficient measurements to get a handle on and understand how this flaw behaves? Okay, so that's it. We need to know, because you're the one raising this as an issue. Please tell us how this actually works. All right, I think I've covered that. Okay. So is this the nonsense you will be presenting to the people paying to attend the International Flat Earth Conference? Because, the trouble is they have no way to know if you're sharing accurate information or your own mistaken beliefs based on your inability to properly operate your equipment, thus leading you to false conclusions. Here I bring up again, direct and reverse, phase 1 and phase 2. He didn't even do that in that test. So his theodolite is looking at a different spot than the level. And if he brought out another level, it would be looking at a different spot, maybe a little bit lower, maybe a little bit higher, because that level is going to be different than the level he has sitting there. Is that the point of your test, Chris, to say all these instruments are different? Well, in your 30 years, in your career, or however long you've been surveying, you're just finding this out? This is basic 101 survey fundamentals. You don't even own this book. And you should own this book, Chris. You should have read this book. If you had read this book, you would never have reached the conclusion you have, and you would not be talking about the differences between these instruments, because it's well known and understood that each instrument is going to have its own imperfections, but that doesn't make them unusable. It doesn't make them inaccurate. They will produce inaccurate results if you use them improperly. There's no doubt about it. So we're going to get to that a little bit later about some of the other things that you said related to that. But again, this is a great book, Surveying Measurements and Their Analysis by R.B. Buckner. That's Ben Buckner. Good deal. Okay. Okay, now, since you do accept that GPS works well, and you use GPS in your survey work, can you tell us how closely your GPS measurements agree with the published positions on existing survey control points that were established prior to GPS using classical geodetic triangulation or traverse? And that's the old brass discs set in concrete or bedrock, set long ago, in the late 1800s, the 1920s, the 30s, the 40s. All of that era was all surveyed using triangulation and traverse. And that's the stuff that he is saying is flawed because of the this imperfection in the theodolites. I mean, that is the case he made. And if I have that wrong, I'd like to hear someone, clarify that for me. I must say, though, that all the comments left in the in that hangout from Sunday night, I asked that question. Everyone says, yeah, that's what he said. So that's what I heard. So that's what I'm going on here tonight as I ask this question. So now what would be the purpose of doing this? Well, because you do trust GPS, obviously you don't believe in satellites, and you say it is operating from cell towers and whatnot, whatever. I mean, we can get into that later, but the basic understanding here is that you believe it works, you do use it, and you are satisfied with how it's working for you. Although you did bring up VRS, and that's a specific method or type of use of GPS, but we kind of got sidetracked on that. But he says it isn't working well, and I have to believe that he doesn't know how to use it. But that aside, he does, and I asked it very carefully and clearly, and he does say that GPS works. And we looked at some examples on farm machinery and on construction equipment. In fact, he raised that. Hey, they're putting it on construction equipment. I played a little video of that. Anyway, so boom, he believes GPS is working. Great. And he's using the method of RTK, where you take your own base station and your own rover, and you use those two receivers together using a radio transmitter. Perfect use of GPS. It's been used for decades that way, and it is still used today that way. So it's perfectly fine. So I'm saying if you trust that, then to verify for yourself whether or not these old triangulation stations are good or bad or inaccurate or not, because you say that those methods far exceeded the use of the theodolite, then go test it for yourself and go check in to some of these monuments. Now, I have an example here. I just go back here to, nope, not that one. Go here. I can close this. Here I am at the National Geodetic Survey Data Explorer. I've just come over here to the Denver area and did a little 20-mile search on just classical stations, not GPS stations. I only have the checkbox checked for classical horizontal. That means they were measured, observed using theodolites, which is the question here, what's being questioned. And that's all I've searched on. And there's lots of them. You can go find these. Well, I just picked one and I brought up its data sheet, and that is here. So maybe I should bump this up in size. So here's one. It's called Arsenal. You have the latitude, longitude, and a height. It's only to the nearest foot because it's not a leveled benchmark. That's okay. You could still verify that position. Here you could see it was produced by classical geodetic methods. If it were a GPS station, if it was determined by using GPS, it would say so right here. So this will be a little test to go and prove out what is the accuracy of this point compared to the GPS. Now you are going to find a difference. There's going to be some difference, but does that small difference measure up to this incredible claim that the inaccuracy of these instruments is what? Well, let me. I'm trying to. Where does he go with that? So it's the inaccuracy in these theodolites that fakes us out or makes us think that the Earth curves 8 inches times the mile squared. Do I have that right? Is that what he's saying? Is that what it is? All right. Well, go find that out for yourself. Obviously, it's just ridiculous. All right, so done with that part. And let me go back to my document. Where the heck am I? I'm sorry I put you through all this. Oh, here's the next one. Compare your GPS vectors to the published lengths of an EDM baseline. So this, I mentioned this the other night, and I've mentioned this before. These baselines exist all over the country. You can find one near to you, and we use it to test our distance measuring portion of our electronic total station equipment. That's what it's for. You can also use it to check your ability to compute delta elevations, because a lot of these have been leveled across. Some of them have. But in any event, this is out there for you to test your own equipment on. And I don't think he's ever done it. So could that be why he has these ideas? Because he hasn't done these things for himself? So again, I'm not picking on Chris, okay? Why am I talking about Chris? Well, because he's the guy that has the YouTube channel. He's Chris Van Matre, the Flat Earth surveyor that, who was it that made some videos about him that he was doing that test out in Utah? Just another flat earther. I don't remember his name. But anyway, look, I didn't go, knocking on his door and going, hey, man, it's not like that. He's the one that's out there. I'm only interested in this because he says he works as a surveyor. He has a career in surveying, yada, yada, yada. He believes the Earth's flat. That is the only reason why I'm talking about him and what he is saying. So trying to have a conversation about it with him. Apparently he doesn't want to do that anymore. Whatever. I'm still going to ask the same questions. And again, these are legitimate questions that anybody else ought to be asking as well. Okay? So, all right, moving on. So yeah, go check into some points, or put your base and rover, put your base on the 0 mark, take your rover over to the 150 or the 450, these are meters, or the 1025, see, and then measure that and see if you come up with the same thing. Well, of course you will. Yeah, that's how it works. So that then also verifies that GPS is matching the EDM on your total station. So you can check that off. Big check. You verified that. By going and checking into this type of mark, you are then verifying or characterizing this inaccuracy you claim must exist in the old triangulation work. I think you're going to find out that it doesn't work that way, Chris. You're going to find out that it's very accurate. Okay? So, moving on. Here's a question. I've been kind of preparing to answer a challenge put out there by a guy named Rayism, my buddy. And I'm asking Chris, if you needed to survey 60 miles of beach in South Carolina, would you use GPS as a reliable method to perform that task? Now, of course, Rayism, his challenge is to just do trig leveling, and that's called trigonometric leveling down the beach for 60 miles. There's no point to that. I mean, all you're going to do is show that sea level, all you're going to do is perform leveling. You're not going to actually measure curvature doing that. I have some counter proposals that I've made on my channel. You can go look at those. But and I'm preparing another one, so let me show you that. I've taken you may have seen some other videos I've done on this AE map, the flat Earth map. I try to tell people saying flat Earth map is redundant. It's like saying sweet sugar or anything like that. Maps are flat. That's what they are. They are flat. The Earth is not flat. So, you'll see so many videos of people putting a ruler on this map and trying to measure from here to here and realizing, these distances aren't working when you do that. Well, no kidding. This is just a printed map on paper, but that piece of paper has no way of relaying to you or showing you the incredible math behind the AE projection or any other map projection. To take a spherical object and map it to a two-dimensional representation, there's a lot of math going on back there in the background. And so when you take it and georeference it like I've done in this piece of software called Global Mapper, I've assigned, I'll show you what I did. I've assigned the azimuth equidistant projection centering on the North Pole, and the longitude of negative 90, so that it's facing up and down the way it is. You can see there's a boatload of projections. I mean, lots and lots of different mapping projections available. So anyway, that's not the purpose of this video right now. But here, I'll show you one thing, and then I'll show you what I wanted to talk about down there in South Carolina. But you can measure distances in here, like you could measure from from there to here, and you notice that when you do that, that line is curved because it's following a great circle. All right. So, it does, like, if I click here and go all the way over here, it's not going to go this way. The only way it does that is if you click here and go down the meridian. You see, if you do that, those distances are correct. The distance from the North Pole down to the equator, you could see the distances are down here in the lower left. That works. But if you go from here and you think you're going to go here, it's not going to go straight across. It's going to follow the Earth's surface that is being represented in a 2D on this 2D map. So the advantage to putting this into a piece of software is that you have that mathematical, the math behind that mapping projection is calculating that distance correctly. Okay. Whoa. So that's how the AE map works perfectly fine if you use it right. It's not well suited for lots of purposes, but hey, you know what? This is the flat Earth map. So here's what I'm proposing to Ray, and I'm asking Chris also if GPS is usable, and we can use this as our basis because this is the flat Earth map. Then we'll just do this whole survey in this coordinate system. So what I did is I went and got all these topographic maps. Let me put this up here. Now see here, these are topographic maps for near Myrtle Beach. Okay. So I think that's Myrtle Beach right there. Yep. Oh, just got covered up by that guy. Maybe I should put, let me put Myrtle Beach up one, maybe. I'm not going to play with that. Anyway, it's behind there. Let me back out a little bit. So we could use this and do the whole survey in this coordinate system, just like the AE map. Why not? It's better to kind of know where you're going, right? So you could do this anywhere. So that's the question. Can we do that survey using GPS, Chris? Is that how you would do it? Or would you take days and days and days to do trig leveling down the beach when you could just use GPS? You could do this whole thing probably in a day or two. All right. I made my point there, or I've asked my question. Where am I going? Where am I? Here we go. Okay. So there's that. And then here, he made this statement, which my jaw dropped. Oh, by the way, I have to reflect on things. Some people think really fast and they can talk real fast and respond quickly. I'm not one of those people. So when you say like unbelievable things, I'm like wondering, what did he just say? He said this. He made this claim that when you repeat your measurements, you increase the error. That's what he said. I'm going to get a transcription of it. And I was like, what is he saying? I mean, we repeat our measurements to quantify the amount of error, to assure that we are getting the accuracy required for the job at hand. You understand, like, if you had to measure an angle to a telephone pole to locate that telephone pole on a map, you would not sit there and measure it 52 times. You know what I mean? You would measure it maybe twice, but generally probably once. It's a mapping point. It's not a control point. You would not spend a huge amount of time trying to measure to that telephone pole from 100 feet away to very, very high precision. That you wouldn't do it. But if it was a boundary corner, a property marker, something like that, you would definitely measure that with several repetitions to assure that you're getting good positional tolerance on that boundary corner. And those things are specified by whoever you're working for. Now, Chris works for he worked for the DOT. So I'm going to show you the DOT's specifications on their website. I mean, he should be familiar with this. He actually was trying to make a claim that this is unnecessary. You should just measure it once. And that's my claim. That's a question here. Since you claim there is no need to perform repetitions of angular measurements because you believe that doing that increases error, how do you assure the accuracy of your work? Hold on one sec. Let me call you back. I'm doing a live hangout right now. I'll be done in a little bit here. Okay. I'll talk to you soon, sweetheart. Love you. Bye-bye. All right. Yeah, so how do you assure the accuracy of your work? By making only one observation. And really, he showed us that himself by this flawed 2-mile telephone pole test. And oh, look, I'm not picking on you, Chris. This is what you're doing. You came on the internet and did that. And I'm a surveyor paying attention to what you're doing, and it matters to me that you're lending like a credibility to the flat earth thing by claiming to understand how to survey, and I don't think you do. Well, at least you're demonstrating that, and a lot of people agree with me in saying that because they're making the same comments after listening to you. And people are not calling into question what I'm doing because I have already made it clear I'm only doing what is published. Like if I was working in Colorado and I was working for the DOT on a project, I would follow their specifications. That's it. No, the comments that I get are, hostile and, just nasty from the flat earth side. So, is that how you want to be? Go ahead and be like that. You're not representing your cause. So that's why I keep coming back to let the measurements speak for themselves. Let's just show me your measurements. Show everybody your measurements. If I was a flat earther going to that conference, I'd be saying, yeah, man, why don't you show us the earth is flat by your measurements? But you can't do that because you already know your measurements are just like mine. And so you resort to this tactic or strategy, or you're just reaching for this idea that no, there's a problem with the equipment. The instruments are bad. They're making inaccurate determinations, thus deceiving us all. I mean, really? Is that you really believe that? And okay. Well, I think you need to do some work to demonstrate that. You really have to demonstrate it. You can't just say it. You can't just show screenshots of an old book. You have to get out there and make some measurements. So, characterize it. That's the point. That's your job. Show us how bad it really is. All right. So anyway, here, this is my cue to come to this website. You can come here, look at the Colorado Department of Transportation. You can pull up these chapters. I opened one here. I downloaded it. Chapter 5. Here it is. And I don't think they would agree with you, Chris, that you should just measure things once. If you look up angle, just search for it in this document, you're going to find that angles must be repeated in face 1 and face 2. They're actually looking for 4 sets of that on some of these specifications. It's all here. And this is standard survey practice. This is not, this is not geodesy. It's just this is the way we operate. They classify these different surveys for different purposes, and this is what you would follow if you had a contract to do work for that agency for a highway project. Okay. I mean, this is not disputed. Well, you're disputing it, I guess. That's up to you. All right, so that's done. Let's see what else. All right. So I concluded here. Hey, did I show you? Well, here's the conclusion, but I think there's something else I want to show you. But anyway, I conclude that Chris Van Matre proves the Earth is a globe, but he won't show you that, unless he comes around. If you're hearing me, Chris, and you go do the L-shaped test I asked you to do, or if you can't take the time to do that, just do one line. Do one line, north-south, 1,000-foot long line with your 1 second Trimble robotic total station measure from both ends. You'll see this. So the fact is, Chris's measurements are the same as mine and every other surveyor working around the world every day. So you could go and look at any of your traverse measurements, and you will see what I've been describing to you, and you will see that you can detect the Earth's curvature in a short distance. I've done it in a park near my house in just hundreds of meters. So that kind of takes away, the reason I talk about these shorter distances is because that takes away this whole idea that, oh, these flaws in the instruments, you're going too far. Well, that isn't true, but if that's what you want to say, if that's your claim, well then measure shorter lines. You're going to see the same thing. Let's see if I, oh, yeah, I did miss something. All right, I'll have to go back. I'll go up. You don't mind, do you, people? What did I? Oh, I don't remember where I wanted to do this, but I'll just do it this way. Here, this website, you've seen this, I've shown this before in a lot of my videos. You can come here, here's Denver, this is the United States. And, click on a map and bring it up. Here, I already have one up here. Maybe I think I wanted to show you this to talk about triangulation, what it was. Some people are looking at these videos of mine for the very first time. Some of you that watch me do this, it's getting repetitive. So, but this is Denver. This is the triangulation that was done years and years ago. These are all the mountain peaks that these measurements were made from. And, I guess the question is that if as Chris claims that these lines are too long, they overextended themselves, they went beyond the limitation of the equipment. Therefore, he calls into question the accuracy of this. Is that where he's going with this? I mean, which is why I said, well, go ahead and take your GPS that you trust and go check some of these. I'm not saying you got to go climb up to this top of this mountain, but man, if flat Earth is that important, maybe it's worth doing. Go make a sojourn and climb up here and check that point with GPS. But look at some of the lines, how long these are. These are incredibly long. lines of sight, and this triangulation was observed and computed in accordance with the methods and procedures I showed you in the in that document up, when I first got started. So the end of this is the end. Chris, before you ran away and jumped off the Hangout, he's saying the burden of proof is on me, but that can't be true because this stuff exists. You have to show us how this is wrong because this exists. These maps are real. All this leveling has actually been done, and that's how we know the differences in elevation between all these places. All this control is what's used to make these maps. There's the airport there. When you get these old topographic maps, you'll see, I'll try to find one here. I did this on the after show with Soundly the other night. You'll see benchmarks, BM, and those are the survey control points done by these guys. Sorry, folks. All these control points are you could almost think of them as like a thumbtack, like sticking the proper coordinate there and elevation to then, create these maps. So if you look at these old topo maps, you're going to see benchmarks, little triangles. There's one. So that right there, over there in South Carolina, that's one of these old survey points right there at the intersection of these two highways. And that's how these maps are made to be accurate. Okay. So the burden of proof's not on me, it's on him. Disprove this. You have to, and that's, look, go back to the very first Hangout we did on October the 21st. In the description box, my invitation to Chris was this. You are a surveyor, I'm a surveyor, we both use the same equipment. You believe the earth is flat. I wanted to talk to him, and I list a whole series of topics. Can you reconcile the measurements that you make, which are the same as the measurements that I make? Can you reconcile that with your flat earth belief? How do you conclude the earth is flat based upon your measurements? And he didn't, on Sunday night, he did not do the test. And then I said, look, go ahead and do it later. Will you do it? He said, I'm not making any promises. Okay. Well, then I guess it's not that important to you. So your belief outweighs your desire or your desire to find the truth. You just believe the earth is flat, but you're not going to take the time to examine what you're doing as a surveyor. And that's why I'm going to proceed with this. The next couple topics I'll be going into is more about GPS, because he uses GPS and he believes it works. So good. I'm going to start in on that for a little bit. And we're also going to do astronomy. We're going to do astronomical observations, solar and Polaris and other stars. And we're going to compare those azimuth determinations, which are angular observations made on the face of the Earth using a theodolite and using precise time, and an ephemeris, which has the spherical coordinates of those heavenly bodies. It has the declination and the Greenwich hour angle. All these things are tabulated, and it works really, really well. I mean, I used to do lots of them in the 80s, before GPS, but it's fun to do. So I'm going to keep doing that. We'll make some videos about that. And I think I've covered what I wanted to cover tonight. It's getting late. It's around 10. Getting to be 10:20. I'm going to say sayonara, good night, and we'll do this again some more. Have a good night, everybody. Oh, wait. I want to go check the chat. Is anybody here? Where's this thing? Come on. All right, let me move that. Here. Oh, people are here. 38 are watching. Good evening, everybody. Yeah, I'm not. What's the web address for that survey map thing? Yeah. You want me to paste it in there? I'll paste it in the chat. This thing. There you go. That's for Joe. Let me scroll up, see what's been happening. Horizon slot. Yeah, he thinks GPS is ground-based. Well, he can think that, but the thing I wanted to find out from him is, does he think it's reliable and does it work? That's all I needed from him, because you know, it works great. You know, it's a black box to him. He doesn't know how it's working. He just doesn't believe that the satellites are involved. But I'm just glad he trusts it and he uses it. Great, because he's going to get schooled about that. I'm going to show him exactly how it works. And people may have heard that I've already done this once, and I'm going to do it again. I surveyed the Lake Pontchartrain Causeway with GPS, but I did it not very dense. I'm going to saturate it the next time I go. So we're going to have a very, very good profile of the bridge using GPS. So that'll be cool. Bill Richards has this question. I've seen him ask me this before. How come if you simply invert the latitudes of a flat Earth map, you can calculate angles to the sun with simple trig like a NASA scientist? I don't know, man. Can you do that? I haven't done that. So is that something you do? Do you have a video about that, or is that have you done that yourself? And can you show us how you do that? Because I've never done that. I want to. Speaking of that, let me go here. I'll open something for you. So let me zoom way out. Here's your flat Earth map, people. What happens when we center it on the South Pole and just flip it around? This is the Great Ice Wall, right? The ice wall's out here. Well, I've taken the same map, registered it coordinately correct, and it looks like that. That's your Gleason map, projected and centered on the South Pole. And there's your ice wall. It looks a whole lot like Antarctica. You like that? If you go ahead and watch the videos I've done on georeferencing this map, you'll see that I did it on Japan, New Jersey, Australia, different places. So I just think it's so cool that the ice wall turns into Antarctica when you flip the thing over. All right, I'll go back to looking at the chat. Yeah, so there, Bill, why don't you give us put in the comments when this thing gets posted up there, link your video to where you do that, this flipping over of the latitudes and whatever. So what am I trying to do? Here we go. Let's see what's... It's been a pretty lively chat. Critical think, absolutely. GPS works everywhere. I've tested that myself in remote areas. So, yeah. This is not true here, Aaron. Aaron, this is, let me help you with this. So the EDM, electronic distance measuring instrument, it's EDMI, is, we all just say EDM. That measures from a total station to a retroreflector back to the instrument. So it measures this, by the speed of light, it measures that distance. So that's at the height of the instrument and the reflector. So it's a slope distance. You know. Now GPS is identical to that. It is not a grid distance. GPS is being measured from one antenna phase center to another antenna phase center. And that's why I tell people to take their GPS equipment, go to an EDM calibration baseline, set it up on tripods, and make that measurement, and you will get the same result as your EDM. The dx, dy, dz, that vector will be the same as that EDM length. Now, the reason you're talking about grid distance is because most people then take that length and use it to compute coordinates on the state plane coordinate system mapping surface, or UTM, or some other XY grid surface. So but the measurement starts right up there between the two antennas. But I'm going to get into that in detail. People are commenting that they're enjoying hearing more about survey stuff, and I've been always reluctant to get too much into the jargon, because it can go over. It's like when you listen to anybody in whatever profession, you don't know those acronyms, or you don't know really the terminology, you can lose them. But so I've tried to keep it for the layman. But hey, people are liking it. I'll get into it. I like talking about it. GPS works because of towers and internet boxes in people's homes. Interesting. That's the other thing. Like when people say, yeah, it works from cell towers. Okay. How? How does it do that? I in the videos I've made on that topic, I've actually linked them to the documentation, which is open source. It shows you exactly what's happening, and it turns out to be that's how it really does work. So whatever. Yeah, John, that's true. GPS worked all over the planet long before the internet was in anyone's homes and cell towers were things. That's true. Hey, John, should we talk about VLBI, very long baseline interferometry? And the fact is that the way we use differential GPS today is based upon the exact same technique. There's software named Global Mapper. Yeah, that's the one I'm using right here. I don't know what you're saying there. I can win $100,000 because I have Global Mapper. Okay, Bill. He says, let's see if you're telling the truth this time, Bill. Jesse thinks you can measure an accurate elevation with an optical system across a 7,600-foot lake and get an accurate elevation. Well, what does that tell you? Well, actually, I don't think that. So why are you saying that? When you say an optical system, are you talking about an auto level? Because obviously you can't measure 7,600 feet across a lake with an auto level. You can't do that. Are you a surveyor, Bill Richards? Let me go down to the bottom and see if Bill's still here. Bill, I'm asking you, are you a surveyor? 10 minutes. Wow. 10-minute delay. Okay, Bill's a surveyor. Okay. Well, how long you been surveying, Bill? No answer. Bill, we'll talk about it later. You know what? If 45 years, awesome. Bill, would you like to do a hangout sometime? Sure. Okay. And are you a flat Earth believer, Bill? A surveyor of 45 years? Yeah, that's good, John. Okay. Well, here I'm not getting an answer back. So Bill, just do this. I would love to do a hangout with you because Chris ran away. I need another surveyor. Need another flat Earth surveyor to. He, I know the math, and it's definitely flat. Okay, great. I love it, Bill. You let's. So you want to do a hangout? That's good. Do me a favor. Just go to my about page on my channel and send me an email from to my email address. And yeah, let's keep it civil, everybody. Scott's a surveyor. How many? Glad to have the surveyors here. How many are there? Other surveyors? Okay, Bill says okay. Good. Yeah, send me an email. Are there any other surveyors in this chat that believe the Earth is flat? Let's do a roll call. I don't really care about talking to flat earthers, but I do want to talk to surveyors that believe the Earth is flat. That's who I'd like to talk to. So that's what I'm asking now. And also then, if I don't get a good a list here in this chat, because I don't know how many surveyors there are in this chat right now that actually believe the Earth is flat. Anybody listening to this later, if you make it to the end here, uh, just email me. I forget what email I have in there. Geodetic Surveyor 2016, I think it is. Gmail. Well, that's true, Aaron. No real surveyor thinks the Earth is flat. That's true. Larry, what do you mean? Why is there only Jesse's audio? Because I'm the only one here talking, Larry. Hey, when did I start this? Oh yeah, yeah, Larry. If you thought Chris was coming here, it's not the case. I'm just proceeding with my questions for him. That's it. So I presented a bunch of questions. Nah, no, he ran away. But I presented. Go back and watch this from the beginning, and you'll see the questions I asked him tonight. And I think other people ought to ask him the same thing. Hey, I appreciate you saying that, Mr. Unite for the Children. I